Okay, today we're going to look at some problems from section 6.2 and 6.4 where we're going to be graphing exponential functions. And this video is only going to be where our base is greater than 1. We'll do a separate video when the base is less than 1, and then we'll come back later on and do another one for our log functions. All right, so all of our transformations that we've talked about with parabolas, which are quadratic functions, and our absolute value, and our square root, and our cube root will all be the same as with our exponential functions. And I'm not going to graph them. I'm going to use the graphing calculator. We'll write down some key things here. And obviously you will be doing it on your graph paper, but that would take a little bit longer, and I don't think you need to watch me graph. All right, so we're in y1, so we're going to graph our parent graph. Y equals e raised to the x, right? Our e is above the natural log. For this one, I've used this window, -5 to 5 on the x, and then -5 to 10 on the y. Just because of the functions that I picked, I think this will give us a complete picture. Okay, so here's our graph of our exponential function with a base greater than 1. Specifically, we're using e. So back over here, right, our domain is going to be all real numbers, or -infinity to infinity. Our range is y is greater than 0. There is no x-intercept. That's because y never equals 0. The y-intercept, when x is 0, we get 1. And then we have a horizontal asymptote y equals 0. So I know we don't see it on our graph, on our calculator rather, but we would be drawing in a dotted line as x gets infinitely small, y gets infinitely closer to 0. Okay, so here the x plus 2, that's going to move the graph 2 units to the left. So we go back to our y equals. I'm going to put this into y2 because I want to keep that as a comparison. So we're going to do x plus 2. And then see, notice that coordinate here at 0, 1 has been moved to the left 2. And so our domain range, all of this has stayed the same. The difference is our y-intercept. If I plug in 0, we're going to get e squared, but all the rest stays exactly the same, but you can see that our graph is moved 2 units to the left. Okay, our next one, e to the x minus 2. Now this is going to move our graph 2 units down. So we'll go to y equals. I'm going to use this one, so I'm going to close the parentheses and then put in minus 2. So it's e to the x minus 2. So you'll see it draws our original graph. Here's the parent graph. And notice the whole graph has been moved down too. So instead of having a y-intercept at 0, 1, it has a y-intercept at 0, -1. So again, domain stays the same. I'm just going to write what's different. The range now is going to be y is greater than -2 because we've moved the graph down 2. This will have an x-intercept. Let's do our y-intercept first. So now instead of at 0, 1 down to 0, -1. And our horizontal asymptote is y equals -2. So we're not actually going to find the x-intercept. It's an irrational number. We would add 2 to both sides. And we're going to have to use logs, which we haven't quite learned yet. So we're not going to find yet the x-intercept. You could do it on your calculator doing second calc, and I'll just do a quick review of that. Second calc, remember that's the 0. We did this back in the second unit. And I want to move down to the second graph. And so it wants a left bound. I'm just going to move it close. There we are to the left of the x-intercept. Now I'm going to move it to the right. Use that as a guess, and you can see it's 0.693. So I'll put that here for you, 0.6930. And you'll learn later on that that's the natural log of 2. Okay, Here now we've got a couple of transformations going on. So I'm going to go back to y equals. I'm going to insert a 3, which is just going to be a vertical stretch. And now inside parentheses, we have a minus 2, and then outside a plus 2. So again, the 3 is our vertical stretch. X minus 2 moves the graph 2 units to the right, and then the plus 3 will move it 3 units up. So we're going to hit graph again. First you see our parent graph, and then the next one, you should notice that we've gone 2 units to the right and 3 units up. So our domain is always going to be all real numbers. Our range now, because we've moved it up 3, is going to be y is greater than 3. Now remember, our original graph y equals e to the x did not have an x-intercept, and since we've moved it up, we still will not have an x-intercept. Our y-intercept, if I substitute 0, I get e to the negative 2. And so we would end up with 3 over e squared and then plus 3. And our horizontal asymptote would be y is equal to 3 instead of 0, right? Because we've moved it up 3. So the y value never gets to 3. Okay, so I've shown you 4 graphs all with base e. I'm going to show you 2 here. Let me just make sure that we're clear our separation. With base 2. And I'm going to leave these graphs because notice, and first what I'm going to do, I'm going to just shut this graph off. So if I go back to the equals, see how the cursor's highlighted there, it's blinking. If I hit enter, what that does is that shuts that one off. So I'm going to put in now 2 raised to the x, because I want you to see the comparison of e to the x and 2 to the x and how similar they are. So again, here's going to be our e to the x, and then the next one, our 2 to the x, right? You almost don't even see it, and then the e, remember e is greater than 2, is a little bit steeper, and that would make sense since it's a greater value, but notice you have the same y-intercept. So all of what we had here for e to the x would hold true to 2 to the x. And now what we're going to do is we're going to put in this and see how similar it is to that. So I'm going to go back to y equals. So this time I'm going to shut off the e to the x because I don't need that. Okay, I'm going to go back to y2, hit enter, so I'm going to turn that one on. And here I'm going to just plug in our new one. So we have 3 times 2 raised in parentheses x minus 2, outside parentheses plus 3. And I want you to see, similar to the e to the x and the 2 to the x, how similar these two graphs are. So there's our e, 3 times e to the x minus 2. And then notice here's the other one. And again, very similar graph. So again, all of this except for our y-intercept, you'd have a 2 instead of an e, would be exactly the same. I hope that helps. And again, you will be graphing these on graph paper, but in terms of knowing the different transformations and how to find our domain, range, x and y intercepts and horizontal asymptotes, hopefully this gives you a good basis for that. All right, hope that helps, and we'll see you soon.